Good afternoon, and thank you everybody for joining another one of our UK and Ireland VCF enablement webinars. Hopefully you were able to watch last month's webinar on Kubernetes on VCF. I call that out. We had some really great feedback on that session. Understandable. A lot of VI admins trying to work out how to simplify the management of Kubernetes in containers. If, like me, you weren't able to attend it or on leave, then the previous recordings are available. I will post in the chat where you can go back and watch them. That one was particularly popular, obviously a very hot topic as we are all now having to consider how we manage and the Kubernetes and containers. As obviously, it's a increasingly bigger part of the infrastructure which we need to maintain. So, for anyone new to the webinar, my name's Carl Bavington. I'm one of the solution architecture managers here at VMware by Broadcom. And today I'll be joined by one of our specialist solution architects, Richard Jones, who's going to talk us through VCF multi-site networking using Federation. But before I hand over to Richard, just wanted to quickly go over some numbers from the Explore on tour we had in London in September. So obviously I wasn't here last month to give you some numbers, but I thought there was some good shout outs we needed to do. So we had 850 attendees, 152 exams were taken, and 173 labs were delivered. Now, I don't have visibility of how many people either passed the exam, but hopefully you got the results you wanted. Feel free if you were Explorer and you passed the exam, please just put it in the chat and we can all give you a virtual clap. Just on that one, if you did pass the exam and you have a VMUG Advantage membership, then go and look into the free VCF licensing you can get, which from memory will entitle you to 128 cores, and that also includes, I think, the DFW, so distributed firewall, and some AVI cores. So that's really a really useful set of licensing to have if you've got a home lab. Based on the success of the event in September, next year we're going to be looking for a larger venue, hoping for a capacity of 1,500 people. The venue hasn't been confirmed yet, so unfortunately there's no date in this slide, but I can tell you it is going to be in November. So as soon as I am aware of more details, we'll call it out in this webinar.
Thank you, Carl. Right, yes. So hello everybody. So my name's Richard Jones. I'm one of the solutions architects working within the VCF division, but mainly focusing on VCF networking. So I thought I'd cover the topic of using basically VCF networking with Federation. So obviously this is included as part of the VCF licensing. So you will basically get access to Federation, obviously, if you've got a VCF license. So without further ado, let's continue. So yeah, this is me. I've been in the organization around 10 years now, just over 10 years. Came from a traditional sort of routing and switching background, sort of Cisco focused for many years. And then, obviously, as I moved into VMware just over 10 years ago. So there are my contact details. If you've got any questions, any follow up, then please feel free to contact me. And obviously, if I can't answer your questions, I'll certainly point you in the right direction. So just on that, let's focus, I suppose, on Federation, right? And obviously Federation with NSX. So in terms of a data center, right? A data center has needs, right, around both the networking and security, right? If we look at a hardware-defined data center, obviously a hardware-defined data center is made up of lots of different component parts from lots of different vendors. So, and ultimately that is then stitched together to provide you with a data center, right, within a location. But then you might have multiple locations, right? And then you're having to repeat effectively the deployment, I suppose, of that hardware-defined data center. There are obviously technologies out there and have been out there to help you, I suppose, operationalize your data center to make it efficient when it comes to things like sort of disaster avoidance or disaster recovery, right? So there are needs, as I say, from a network perspective, but also a security perspective. And I say that can be quite complicated and convoluted when you're defining this based on the hardware, right? So as I say, you're standing up lots of different hardware. You're trying to stitch it all together within a data center, and then you're trying to stitch it together, obviously, between multiple locations, right? And there's always been a challenge, I suppose, when we talk about, I suppose, maintaining security policy, right? So how can we run our firewalls and how can we get our policy distributed across multiple locations? And actually, that might mean maintaining multiple different firewalls with multiple different policies and actually having to update those at the same time, right? And then how do we actually maybe retain the IP addresses of our virtual machines, right, as they move around, and as they maybe they move from location A to location B, but there is no option to stretch layer 2. So maybe you're having to re-IP address the applications and the VMs and then re-advertise different subnets externally, right, to obviously get that communication back in. So as I say, it can be quite complex, right, to operationalize environments across multiple locations, right? So what if we could overlay, I suppose, a global policy, right? So what if we could actually deploy something where we can actually stretch layer 2 networks between multiple locations, and then we can actually have our firewall policy and our network constructs maintained across multiple locations, right? If we can do that, that's then going to help us, right, when it comes to invoking things like disaster recovery or providing sort of disaster avoidance or potentially running our data centers as active, right? So rather than having assets running hot in one location and then running cold in another location where you can only run as active sort of standby, what actually if we can use all of our infrastructure, right, use all of those component parts and actually make our data centers much more efficient, right, and actually utilize them in an operational state when we're up and running, right? So from a VMware perspective, and you might have come across this, there are a couple of options when it becomes a conversation around single or multiple NSX domains, right? So when we talk about a single NSX manager, this isn't Federation, by the way. This is just giving you a bit of an insight, right? From a VCF standpoint as well, we can do this, right? We can run effectively a multi-site deployment, and we can run effectively something called a stretch cluster, right? So we can run a stretch cluster between multiple locations, but there are some caveats to that, right? So one would be sort of round trip delay, obviously low latency between our data centers. Another is when we're deploying NSX in this fashion, then we require a sort of a larger MTU size because we can't use fragmentation. But obviously there are some benefits to this architecture, right? It is simplified. You are using a single set of NSX managers. You get a full feature set across this deployment, right? From an NSX perspective, so you get access to all of the features and the functionality that comes with NSX. But as I say, there are some caveats to this design. So this is what we call sort of the NSX sort of, I suppose, multi-site design. Obviously, and first and foremost, yeah, it's running effectively what we call a stretch cluster. So the one we're really interested in today is this one, right? So this is NSX Federation, right? So NSX Federation offers some of the same benefits, right, as the one I've just previously described. There is a smaller set, I suppose, of features that it supports, and it's still quite feature rich, but it's not as feature rich, I suppose, as the option before. But there are some major benefits, right? So ultimately, from a connectivity perspective, we can support fragmentation. So we don't require that sort of larger MTU. So if you are constrained by, I suppose, the size of your MTU, then we can run fragmentation, right? So we can effectively operate across multiple locations using fragmentation, but having a single NSX environment, right? Where, yes, these are discrete NSX domains, but we can effectively federate them together to provide effectively consolidated networking and sort of consolidated security across those environments, right? This also makes them sort of quite discrete as well as sort of separate environments. So you can sort of still target the local NSX managers as well. So if you have a requirement that only needs to exist, for example, in location A, we can actually still target that local NSX manager, right? So we don't have to deploy everything at a global level, right? So there's a couple of different options, right? And there's a couple of, as I said, a couple of different flavors around sort of single versus multiple NSX domains. And again, it really comes down to, I suppose, working with your account teams, working with your SAs to maybe better understand what those look like and actually how they best fit your use cases and your requirements. So yeah, ultimately there is again a UI and an API for the global NSX managers, so we can target those through both of those options, and then we will effectively push policy down to the local NSX managers. So once we've done some configuration at a global level, we'll then push it down to the local NSX managers so they completely understand what's going on and obviously what we've built from a global level, right? So some of the benefits, like I've already talked about, is simplifying, I suppose, the operational state of the environment, right? If we can target a single set of managers, but then we can push policy across those local managers, it's going to simplify how we're deploying our data centers, right? So like I said earlier on, when we talk about sort of hardware-defined sort of data centers and multiple locations, where you're configuring multiple different vendors' equipment across multiple different locations, what we're doing here from an NSX standpoint is simplifying that, right? So we're offering the global manager. That's where we do our configuration, and then that configuration is then dynamically pushed into those local managers. We will have consistent policy enforcement, right, across those environments. So location 1, 2, and 3, for example, will share information around the networks and the security that we've configured at a global level, right? So they completely understand, they're completely in control of what's going on within their own environment, but also what exists in those other locations as well. And like I said, compute mobility, right? How we can move VMs from location 1 to location 2, maintaining the networking connectivity. So we're stretching that layer 2, so the VM or the application maintains its IP address, but it also maintains its security policy, right? And its security posture. So it's always secure, right? It's always in compliance. It's never out of compliance, ultimately, because obviously we're pushing that VM and we're maintaining the policy, right? When that VM moves, right? And as I said, it will simplify DR, right? With the use of NSX, the stretching of the networks, the rerouting of the traffic, right? Dynamically from location 1 to location 2. And also with additional tools like live recovery, SRM, as you also know it as, we can move VMs from location 1 to location 2 or location N+1, and ultimately simplify how we invoke disaster recovery, right? From a management perspective, we've got a couple of things going on here, right? So one is we have those local managers, right? And they will always be deployed as part of a VCF deployment, right? So you'll always deploy local NSX managers. And let's say you can target those local NSX managers, right? And then we have, as I say, this set of global NSX managers, and they will reside on one of those locations and obviously the management cluster, right, of that location. We then have a standby set, right? So we have a set of standby global NSX managers just in case, obviously, we lose the global ones, right? And then we will effectively, our local NSX managers will obviously communicate and register with our global NSX managers. So our global NSX managers are now aware of the local sites, right? The local locations that we've got and obviously where we've implemented an NSX domain. Then what we've got is effectively the ability, like I said earlier on, to be able to stretch our networks between certain locations. So in this example here, we've got a network that is stretched between location 1 and location 2. We're also stretching the routing, right? So we're also stretching the routers that we've got deployed in the virtual environment between those two locations, right? And then effectively, once we've configured that at a global level, we then push that policy down to obviously the local managers, obviously, that require that information, right? And we haven't configured location 3 as part of this. So actually, we're only pushing that policy and that configuration down to location 1 and location 2, right? And actually not pushing it to location 3. In terms of the grouping as well that we can define here, you can see we've got effectively group 1 defined. We can then define that across effectively those multiple locations. So we're defining location 1, 2, and 3 as part of group 1, right? So when we push that policy, we then push effectively all of that policy down to the 3 locations and obviously down to the local managers. So now we've got that network stretched across all 3 locations, right? And then obviously we've got the VMs that sort of sit within those locations, and then we will synchronize the configuration, right? So once we synchronize the configuration at a local level, the local NSX managers are aware of where the other VMs reside, right? So we can see that, yeah, for example, in location 1, it knows effectively about VM 1, 2, and 3, and it will know where those VMs reside and where they exist. And obviously, if they need to communicate at a layer 2 level, it'll know that actually it's got to go external if we're communicating from VM1 to VM2 or VM3, right? So it'll know that it's got to go external, and then it'll use the layer 2 over layer 3 connectivity that we've built into the platform itself. So in terms of the UI, yeah, you effectively end up with, as I say, access to the global manager. So you can access it through the UI or you can target through API. Once you've done that, effectively, you'll get effectively this GM underscore Paris, for example, at the top. Obviously, that can be obviously named depending on where your data center is. And if you do the drop down, then you can actually also gain access to the local NSX managers, right? So you're not having to log in to all of them independently, right? If you want to target them, if you want to provide configuration on them, you can actually just do it from this central location, right? So where you log into the global manager, and then actually we can then land on the local manager London or the local manager Paris, depending on where we're going to push policy, right? And then you can see here that we've got effectively the GM Paris is our active set of cluster, is our active cluster, and then we've got GM is our standby set. And then again, these are our locations, right? So this is again where we've gone in, we've spoken to the local manager, and we've told it about the global NSX managers, and then obviously we've pushed that information up to the global level, so they are now included when we're building out policy at a global manager level, right? So also on that, obviously, yeah, we're pushing effectively the local intent, right? So we can still log in, like I said, to the global manager, and then we can still push all of that configuration down to the LM, right? We can also still directly target the local managers, right? So we don't have to go via a GM. Like I said earlier on, if we've got configuration that we only want to push to a local site, and we don't have a global requirement, right, for stretching layer 2 or stretching the routing between locations, and our VMs and our applications are only going to reside, for example, in location 1, then we can absolutely still just target the local cluster, right? We don't have to define everything at a global level. And then in terms of security use cases, again, we can target the global manager, we can create global groups, and we can then define those groups, and obviously we can define the membership of the VMs within those groups. So for example, this one is a global services. So we've got things like DNS or NTP obviously running, that we obviously want to effectively group together, whether they're running in location 1, 2, or 3, right? So we can do that, right? And we can also break down in a regional level, right? So again, location 3 is probably out of region, but we want to actually just define some services that run within region, right? So location 1 and location 2 within region. Or we can define, like I said, local services, right? So we've got a set of local applications across 1, 2, and 3. But again, we can define policy still from the global manager, but actually only make that relevant to the local VMs and infrastructure, obviously, that's running in each of those locations, right? But then we can also have a mix, right? So we can also have a mix of firewall rules, right? So we can have rules that's obviously are mixed and obviously that span the environments, right? So we've got options, right? There are lots of different options, obviously, when you're, I suppose, looking at federation, and you've got a use case for federation, depending obviously how you want to define the policy, define your security, how you want to embed that into the distributed firewall. Then there are options, right, around creating those groups and obviously where you're pushing the policy. And then we can do things like dynamic inclusion, right? If we are using NSX security groups and we are defining NSX security tags, we can create tags, we can apply those tags to VMs, and then we can obviously dynamically include VMs into groups, right? So it's quite a powerful tool if you're defining like this way, and you're defining tags and then you're applying the tags to the VMs. As soon as you apply a tag to a VM, it's automatically going to assume the policy that's defined as part of that. If that's the criteria you're using to get the VMs into security groups, then that will automatically happen as soon as that VM gets that tag. In terms of network use cases, sorry, we've got a couple of options, right? So one is, that we can, from a GM level, right? We've got options around what can be local and what can be stretched, right? So again, you've got some options around you're designing this as to what you want local and what you want stretched, how you want to maintain that connectivity, what that connectivity looks from an active standby perspective or active, or whether you're doing things like local egress. There are multiple different options. As I said earlier on, right, it's not a full feature set, so you don't get all of the features that you would do from a single NSX manager, but it's still quite feature rich. So again, it just comes down to comparing what option best suits your requirements, right? So yeah, just be mindful that, as I say, you don't get a full feature set with Federation. You just need to check that actually Federation will suit your use case, and then you get all of the options that you require from Federation if you want to go down that route, right? So yeah, lots of different options around whether they're stretched segments, local segments, non-stretched segments. Multiple choices when it comes to that. So in terms of use cases, this is the active standby one. This is obviously where we're using sort of disaster recovery. We've got our global managers deployed. We've then got a set of local managers. We define effectively what the network looks like, right? So we've built a network construct, and you can see here that we've got the outside world is at the bottom here. For me, this diagram is slightly upside down. Normally, I draw the outside world at the top. But our outbound connectivity to our physical, our corporate network is at the bottom here. So we've defined effectively an NSX T0, which spans both sites. And we've said that its primary location, or it's primary in location 1. And we've said that the T1 is primary in location 1 as well, right? So we can be quite deterministic, right? Because this might help us if on the outside of our NSX environment, we've got a stateful perimeter firewall, for example, right? We've got a stateful perimeter firewall, and obviously it needs to maintain state information. So this one, we can effectively, we're choosing the route inbound and outbound, right? To force it to use location 1 under normal conditions, right? So we can see here, we advertise our BGP. So we've built that BGP relationship between our tier 0 and our our tier 0 and our outside world. And then we are effectively sending our BGP routes, but in location 2, we're actually prepending the AS number, right? So it's less preferred out of location 2 for the return traffic, right? So our inbound traffic is going to come through location 1. All of our outbound traffic is going to go out of location 1. So you can see that obviously if that's the case, then we've got a firewall on the outside world. As I say, this is a good design for us, right? We can maintain this. We can maintain the connectivity. We're not doing any asymmetric routing here. Under normal conditions, we know exactly what's going to happen, right? If for any reason we lose our data center, ultimately, we're then going to relocate, or our BGP is going to obviously become preferred, right, as the return route. And then the traffic will return in, obviously, through the secondary location. And then we're going to SRM effectively. So we're going to use another tool, right, to relocate our workloads from location 1 to location 2. So once we've done that, the default gateway back out becomes through location 2, right? So we know exactly what's going to happen, right, if we obviously lose the primary data center in this use case. And yeah, we've not really had to make any changes to the physical fabric, and we've not had to change anything to the NSX GM or LM, right? And obviously our IP addresses of our VMs have stayed the same because we are stretching the layer 2 over layer 3. The only thing we've used is our SRM, right, to recover the workloads themselves. The second use case here is we're running active, right? So like I said earlier on, we want to sweat all of our assets. We want to run our location 1 and location 2 together. So we're actually using all of our infrastructure. What we've defined here is a couple of different things, right? We've got effectively the ones in yellow, gold, and blue. We've got 2 sets of infrastructure, right? So we've got 2 network constructs that we've defined, right? So we've defined separate tier 0s, separate tier 1s, and separate NSX segments, right? And we've got our workloads obviously sitting across those, right? But you can see that for the blue networks, the primary is out of location 1, but actually for the yellow networks, the primary is out of location 2, right? So we are actually going to use both data centers, and we're going to, as I say, run our networking so that our routes are preferred in the opposite direction for each of those network types, right? So again, you can see that obviously on the outbound side, we're actually going to be utilizing both locations, right? So you can see for blue that it's going to use obviously location 1 for its inbound and its outbound, and then between the two data centers, it's going to use the data center interconnect, right? So obviously when we stand up the environment, we're going to have this data center interconnect that obviously builds the adjacency between the hosts in both locations, and then builds the underpinning layer 2 over layer 3 using obviously the Geneve protocol, the tunnel endpoint technology that we've obviously got with inside NSX, right? And then on the yellow network, yeah, we're preferring location 2, right? So yeah, you can see that obviously we're now using location 2 for that traffic. And then we've got, if obviously we lose the primary site for blue, we're then going to recover obviously into location 2 for obviously that for that blue network, right? So obviously then that becomes inbound and outbound based on obviously the dynamic inclusion of obviously the dynamic nature of obviously the routing protocol, in the fact that we can then we're advertising the subnets out, and then obviously we're using a different default gateway on the way out, right? Using that secondary location. So all good on that side. Yeah, we've talked about the default route. And again, we've managed to do this. So in terms of this active disaster recovery, where we've not made any changes to the infrastructure, right? We've not done anything to the physical fabric. We've not had to change anything in NSX from a GM or LLM perspective. And we've not even recovered our workloads using SRM, right? Because in this scenario, we're actually, I suppose, more running disaster avoidance. The application is spread across both locations, and we've got VMs in site 1 and site 2 effectively doing the same job, right? So we can just target, obviously, those VMs that still exist in that secondary location. And then the third option is around, I suppose, active with local egress, right? So this is a bit of a halfway house, right? So we can configure effectively local egress where we have effectively primary in location 1 and location 2. What this means is on the outbound, so when we're sending traffic outbound, we're actually using both locations, right? So we can use both locations. So again, we can use all of our assets. We can use the outbound connectivity out of both locations. On the return, however, we are still just preferring one location, right? So we're preferring one location, and then we are obviously using the data center interconnect to be able to get between obviously the VMs in location 1 and location 2. So again, if we lose the primary site, the subnets are still advertised out of location 2, and obviously we can obviously target those, and then outbound traffic will obviously continue to use the default gateway. You do have to be mindful with this one though, around that whole sort of asymmetric routing possibility, right? Because if you're running local egress, and like I said, and if you've got something sitting on the outside of your network where you're running a stateful service, ultimately you've got traffic exiting both data centers. So unless you've got that capability where that firewall can obviously run active across multiple locations and understand the state information obviously between those locations, then you might run into challenges, I suppose, with asymmetric routing. But if you've just got routers on the front of that, then it may well be that this could be a solution for you, right, where you're using local egress. So just on that point, I'm now going to break out into a demo. So hopefully my screen is going to work. So this is what we're going to do, right? So I've got a couple of exercises that we're going to run through. So where we've got a local manager, and then a couple of local managers across 2 different sites, and then we've got the global manager. So we're just going to run through this demo, right? So you can see the environment here. I've got a lab environment. As I say, this has been playing up a little bit, so I'm hoping that the demo gods are with me. We've got effectively a holodeck implementation, right, where I've got effectively site 1 and site 2, and then I've got the federation components where we've got global managers and local managers, right, for both of those sites, right? So I'm currently logged in effectively to the Site 1 vCenter here. And you can see the VMs that we're interested in really are Web 1, Web 2, and the database, right? So very simple. We've got 2 web servers and then we've got a database backend, right? If I look at the secondary sites, this is my secondary location. I don't have any VMs running in here, but what we do have, and when we get to the sort of the SRM bit, is we've got a couple of placeholders, right? So I've got a placeholder here for DB01 and Web01, right? And then I've got login effectively to the NSX Global Manager. So apologies, this is timed out. So if I just log in, what I'm effectively going to show you is at a global level. Like I said earlier on, right, I'm logged into the global NSX manager in Site 1. I've then got the capability of going into each of the local managers, right? So again, I can go into those local managers and obviously I can configure those independently of what I've defined in the global NSX managers, right? If I then look at the networking, I can look at effectively my tier 0 router. So I've got a global tier 0 router. And you can see here, right, the primary is Site 1. The secondary is Site 2, and then I'm using edge clusters which are defined at a local level, right? So I've got a couple of edge nodes which are sitting in Site 1, and then I've got a couple of edge nodes sitting in Site 2. So they're the devices that are going to effectively do all of the inbound and the outbound routing for me. I've then got a T1 gateway or a couple of T1 gateways. The one we're interested in is this one, which is stretched across the 2 sites. And you can see that it's paired effectively with this sort of the global tier 0. And then I've got a couple of segments, right? I've got the database segment, which you can see is defined in here. And you can see I've got a web seg as well, which is defined in here. So these were created at a global level, right? If I log into the local NSX manager, apologies, just timed out again. Not easy when you've got an NSX password that needs to be 12 characters long. So this is effectively Site 1's local manager, right? So if I look at the networking in here, I can see that I've got a global tier 0 and it's a global device. This has been configured at a GM level. It's then been pushed down, obviously, into the local managers. If I look at the segments, you can see here, I've actually got those segments. I've got the DB seg and I've got the web seg. So obviously I can use those and I can put my VMs onto those segments, but they're configured at a global level, right? So their ownership is the global NSX manager, right? And that would be the same for the other 2 sites as well, right? So just going to flick back to the notes in here, right? So we've got, as I say, that's the setup, right? And you can see here, this is exactly what I've got, right? I've got 2 sites. I'm advertising BGP out of Site 1, and then I'm advertising it out of Site 2, but I'm prepending the AS number, obviously with these 2+ symbols, by a couple of AS numbers. I've then got this global tier 0, which stretches between the 2 sites, and then I've got a global tier 1, which stretches between the sites. And then my VMs, my web server 1 and 2, are attached to the web seg. And then I've got the database segment, which is where my database is sitting, right? And I've already showed you this, right? I've logged in. I've showed you, obviously, that we've got the GM and obviously where the 2 locations are, right? Site 1 and Site 2. So in this scenario, right, our outbound traffic or inbound and outbound traffic is effectively going to go in and out of Site 1, right? So I've got connectivity inbound and out of Site 1. What I've also defined is a policy, right? So I've got a security policy defined at a global level, right? So if I look at security in here, I look at the distributed firewall from a GM perspective, you can see here I've built a very basic policy around our application, right? So we're allowing any inbound traffic to talk to our web group. And if I look at our web group is made up of effectively 2 virtual machines, Web 1 and Web 2, and it's got 2 IP addresses behind it, right? So the one thing, as I say, if you're new to NSX, yes, we abstract away from, I suppose, using IP addresses as part of policy, right? We tend to use things like security groups or logical switches to build network constructs. So we don't need to necessarily know what the IP addresses are or the subnet ranges are. But ultimately, under the hood, right, that's what it's using, right? NSX understands the inventory of the vCenter. It understands, obviously, where the IP addresses are, what the VMs are. So it will obviously use those when it's when we're pushing policy and obviously when it needs to invoke policy. But ultimately, we're defining the inclusion of our VMs using different criteria, right? We're not using the criteria as the IP addresses. But yeah, you can see here we've got Web 1, Web 2, and they're the IP addresses associated to them. We've then got a second tier, which allows our web group to talk to our DB group. And very similar, I've got one virtual machine in my DB group, which is the IP address of my DB server. And that's using MySQL, right? And obviously on the front end, we're allowing ICMP, and we're allowing HTTP and HTTPS. And then effectively, we've then got this reject, right? And this reject will always be there, right? Because when you're defining NSX policy, you effectively want to allow obviously the communication for the application, and then you want to put an implicit deny at the bottom of it, right? So you catch everything, and obviously you prevent unwanted communication channels and unwanted traffic, obviously using that, right? So that's the example we've got in terms of the policy. So what I'm going to do at a very basic level is show you that I can access my web servers, right? So you can see that I can access the web server, and it has access to the database backend, right? So that communication is there. I'll just refresh that again. And then if I do the second one, I can also access, my second web server, right? So I've got the two web servers there, and they can both communicate with the database backend, right? All good. What I'm then going to do is I'm going to change the firewall policy at a global level, right? So I'm actually now going to change this to a reject, right? So I'm going to reject the policy from a back-end perspective. So I'm going to deny the communication from the web servers to the DB servers. I'm then going to push that policy, right? So I've pushed that, as I said, at a global level. I can show you at a local level as well. So I can show you the security at a local level. So again, I log into the distributed file. You can see here this policy, it's owned globally. Now what you can see is you can see the reject, right? So you can see that that configuration has been pushed from a global level. It's now been accepted by the local NSX managers. Obviously, that's what it needs to basically deploy into the hypervisors when we're obviously running DFW, right? And then if I try my application again, you can see that I now don't have access to the database backend. I can still access to the web server because obviously that's still there, but I can't communicate with the database backend. So fairly basic, but I think it gives you basically an idea of obviously what we're trying to achieve here, right? So now what I'm going to do is I'm just going to flick that back again, sort of at a global level. I can now permit this and I can publish it. Just quickly show you the local NSX manager. So if I just refresh this, so at a local level, we're now back to an allow, right? And I've now got effectively that communication back, right? So we're good. Second point I'm going to sort of show you is how we can obviously do a vMotion between sites, right? So what I'm going to now do is I'm going to move Web 2, Web 02 effectively to the second site. So when I move it to the second site, it's going to keep its IP address, right? So it's going to stay on the same IP address range. It's going to have the same firewall policy applied to it. So it's not going to lose any connectivity, right? But it's still going to be secure. But it is going to move between two locations, right? So what we're going to do just quickly is I'm just going to prove the configuration to you, right? So I'm just going to run a trace route effectively to that VM. I hope my fingers work. So trace route 20.20.20.12. So you can see it's basically going through site 1, right? So it's using the tier 0 in site 1, it's using the T1 in site 1, and obviously it's getting to the actual web server itself, right? The second part of that is I can do then a continuous ping, right? So I can do a continuous ping to 2020.12 minus T. You can see I'm doing it live. Right, so the ping is running, right? And we're getting effectively sort of 2 milliseconds, 1 millisecond response times, right? What I'm then going to use is I'm just going to use a simple PowerShell script to relocate that VM between site 1 and site 2, right? So that's now running, right? And I'll just prove that that's running. Takes a little while. It takes around about sort of 3.5, 4 minutes for it to move it. As I say, it is a lab environment. It's a shared environment. So sometimes it takes a little while to do that. So once that starts going, I'm just going to show you that. So you can see that it's relocating the virtual machine. You can see here in recent tasks that it's now going to relocate that virtual machine. So just on that, I'm just going to flick back to some of the slides just to cover some things that that you might want to know. just around requirements, licensing, orchestration, obviously, and then sort of scale and design, right? So there are some requirements, right, around running, I suppose, the GMs and the LMs, right, that they need to be on sort of 4.1 as a minimum. You need less than sort of 500 milliseconds, obviously, between those sites, like I said, right? And that's not bad, right? Because if you look at things like, as I say, when I talked about NSX multisite, look, I told you about sort of stretch cluster, the requirement for that is going to be less than 10 milliseconds, right? So again, if you're running sort of that type of environment, maybe a stretch cluster is a good option for you. But if you're not, and actually you still want to have sort of centralized policy and configuration, then federation may be the answer, right? Yeah, obviously, ultimately there is obviously the whole sort of GM to LM, LM to LM connectivity with or without NAT, and edge node connectivity with or without sort of NAT, obviously, and we need what we call sort of RTEP traffic. So RTEP traffic is the traffic where it uses the edge nodes to build tunnels, right? So we've got edge nodes at each location. When we want to stretch that layer 2 between those locations, we can absolutely do it. But what it'll do is it'll use those edge nodes, so those edge node VMs or hardware VMs, depending on, sorry, hardware edge nodes to basically build the tunnel. So we can then do that layer 2 over layer 3, right? And then obviously there's a couple of other things around sort of no bandwidth requirements, no bandwidth requirement, sorry, no MTU requirement. So yeah, if you can avoid obviously doing fragmentation, that helps. But if you can't, because obviously you can't get to sort of 1700 bytes, then we can do fragmentation, but obviously there's a trade-off, right? So in terms of obviously, I suppose, throughput latency, do you know what I mean? Things like that. Then obviously you're going to have a bit of a trade-off in terms of performance over actually sort of getting the thing actually up and running, right? So you can avoid that, then we recommend doing so. But also appreciate that this also might be customers that maybe have things like encryptors in the way, right? So encryptors, obviously, generally you can't run higher than sort of 1700 or 1500 bytes. So we're sort of stuck. So federation might be the better option there, right? And then obviously sort of things like data plane recovery, there's a couple of things, right? If you're advertising public IPs, those need to be sort of owned by the customer and obviously not the internet provider, right? So obviously if the internet provider owns them, you can't advertise them out of both locations, right? You have to only advertise them out of where the service provider is allowing you to do so. So yeah, just a couple of things on that. A couple of things around orchestration. We can absolutely orchestrate federation. Like I said, we've got API. We can target it. We can do everything through API that we can do through UI. There's some integrations there, obviously, with the NSX API, but also things like Terraform, Power CLI, and Ansible, right? So there's just a couple of URLs on there that might be of interest. But yeah, fully automatable, and yeah, so you can do everything through an automation rather than through a UI. Again, there will be sort of things like scale limitations, right? So when we're talking about things like federation, as I say, there will be some scale limitations on number of NSX domains you can support, but also things like yeah, overlays, rules, policy, that sort of stuff. So again, check out configsmax.broadcom.com for more information on that. So back to the demo, I'm hoping that our VM has moved. So you can see our VM is now existing in Site 2. So if I just show you vCenter 2, you can see we've now got Web02 in here, right? The point here really is that obviously from a VM Web01, we can still target the VM. And from a Web02, we've still got access, right? So we've not changed the IP address. It's still sitting on 2020-2012. And it can still access the database backend, right? So that's effectively what we've done, right? We're now coming into Site 1. We're then using the data center interconnect to get to Web02, and then obviously it's returning back to location 1, right? And I get that at the end of the day, there's quite a lot of tromboning of traffic here. There's probably, depending on how you design your infrastructure and obviously how you want to run your applications, you probably wouldn't do this, right, in terms of obviously a normal operation, right? So you probably wouldn't have Web02 sitting off to the side accessing a database in site one, right? It may well be that you sort of design it slightly different, that everything runs in site one, or even you've got database access in site two, right? There are different options. It's really just showing us that we've got that capability of not having to re-IP address the VMs, but actually move them between locations, right? If I then quickly run a trace route back to that VM, you can also see here that the round trip delay has jumped, right? You can see that it's gone from 1 or 2 milliseconds in site one. You could also sort of see there, and I can't get back to it, I don't think, there was the little blip where it flipped over the VM, right? So it sort of flipped the VM from site one to site two. It's there, look, you can see it. So you can see that it flipped from site one to site two, and you can see that, right? If I run the trace route, so I don't want to do that. That's not in there, right? So that's fine. Oh, it's on here. So if I run the trace route here, you can now see that actually it's still using site one, right? So you can see that actually, even though I've moved that VM, it's still using site one to obviously get to that traffic. So again, we're obviously being deterministic in the way that our traffic routes, because as I say, on the outside, could well be that we've got a stateful firewall, right, running in there. Yeah, and the other thing I can do, that's worked. I'm just going to do something else. Yeah, I can then change the firewall policy in here just to do something similar. So I can reject the traffic. I can push that. This is now pushing that policy not in only into this NSX manager, which is on site one. We know that. We've seen that happen before. It's also pushing it into site two. So this is the NSX manager for site two. And you can see that if I just quickly look at the distributed firewall, we've then got, yeah, a reject in here, right? So I can then effectively, yeah, I've lost access to the back end, right? So just mindful of time. What we're now going to do is we're just going to quickly shut down site one, right? So we know that everything at the moment is running through site one. I'm then effectively going to invoke effectively a shutdown of site one. So if I do that, and I can continuously run this ping. So let me just run this ping. Sorry, till it's live. All right. So now if I go back to here, right. So I'm just going to take down effectively access to site one, right? So site one is going to go down. So site one is now disabled. Did I change the pod? Oh, there you go. So you can see that it's flipped over. So now it's flipped over in terms of obviously the traffic. It's rerouted the traffic from the site one edges and obviously the BGP into site two, right? So if I rerun the trace route, you can now see that we're now going through site two, right? So we're going through slice two to get to that second VM. Okay. So we've lost that, and now we know that the traffic is coming through that second site. And then the third piece really is that we don't have access effectively to the database backend, right? So if I show you this, we know that we've killed site one, but actually VM01 and the database VM are sitting still in site one, right? We don't have them in site two. So what I can do is I can bring those VMs up using Site Recovery Manager, right? So if I run up Site Recovery Manager in Site 2, so I can do that here. So I'm just going to log into that, launch it, and then effectively have what I call a recovery plan, right? So I've got a recovery plan that says those two placeholder VMs that I've got for DB01 and sort of Web01, I want to invoke those, right? So I can click on the recovery plan. I can log in. Oh, sorry, that's the login. I can log in. I've then got this recovery plan. I can highlight the recovery plan. I can then run it, right? So I'm now going to effectively run the recovery plan, and I'm going to set it to disaster recovery, right? So I want to just run that. I think I ticked this one. Yeah, so that's good. And then I'm going to finish, right? So this is now invoking that recovery plan. So what this is going to do, you can see here in the second vCenter that it's actually running that recovery plan, and it's actually going to bring DB01 and obviously Web01 up in site 2, right? So again, it's a couple of different tools. So obviously it's NSX providing the infrastructure, it's NSX providing the underlay, it's NSX providing the stretch and obviously the rerouting of the traffic and the security policy. But obviously alongside additional products that are within the VM, within sort of the portfolio, we're now bringing those VMs back to life, right? So we're actually now bringing them back up in site 2. So, and obviously all of this can be fully automated, right? So yes, I'm showing you obviously that I'm sort of invoking these things manually, but obviously it can be obviously fully automated in terms of obviously recovering those VMs, right? So if we just let that finish, once we go through, hopefully that's the second site. If I then just bring up another window and I connect to Web 2, so it's still down at the moment. Always takes a little bit longer than you want it to. Yeah, it's taking a little while. Come on. So yeah, so just on that, as I say, it is around sort of that GM, right? It is about how we can effectively have multiple NSX domains, individual VCF deployments, which we can have, and then we can have those as discrete deployments. But actually, if you've got a requirement to provide infrastructure at a local level, but also infrastructure at a global level as well, where you want to actually be able to run your applications across site, recover those applications across site, obviously simplify your disaster recovery, your disaster avoidance, do you know what I mean? Reduce the amount of downtime. Then ultimately, yeah, we've got that ability to do that, obviously using this federation use case, right? So the last piece really is you can see that those VMs are now up and running in the second site. Can I access the web server? No, that one's not working. It's not quite up yet. I think the VMs are still down. So let's just give it a second. But yeah, they're just coming up. But you can see that they're live, right? You can see we've got DB01 in here. And you can see that we've got yeah, Web1 as well now running in these locations. Right. I think on that note, I'm going to move on. Taking a little bit longer than I hoped. Actually, let me just check. This is the problem. Right. Let me publish that. So we've now set that and allow. I've knocked myself off. So I've relocated the VMs and now the VMs are live. All right. Excellent. Okay. On that, I'm just going to flick back to the slides. Just some next steps, really. One is if you're interested in sort of learning a little bit more, then please look at sort of hands-on labs. So free to register, free to access, gives you access to multiple VMware sort of environments, and you can go out and try and test out. And then also this webinar series, I know that obviously you've all registered for it, but if you want to spread the word and obviously get others to register for it, really appreciate that. So on that note, thank you very much.
That was Richard. Thank you so much for navigating that live demo. Yeah, I think we learned a lot around NSX Federation, and we also had some SRM chucked in, and it all worked. So that was an impressive feat to be able to get that done in the time. If it's okay, Richard, if you could just flick back to the sort of big early slides on the user con, just a couple of points. Conscious we ran over, but obviously everyone will appreciate there was a lot of content we went through there. So
let's go back. Don't want to
keep it
mess around with the presentation, but yeah, there's a lot here.
Yeah. So what I wanted to just quickly call out, I know we mentioned about the exams and as part of Explore, but also anybody who was at Explore on tour would have realised there was the VMUG UserCon. So VMUG UserCon, sorry, previous slide. used to be the national UK event for the VMware community. That is evolving now. So in order to provide a bigger environment running over more days, more content, the VMware community have decided to do VMware Connect. So next slide, please, Rich. So there's a link there. So if you haven't heard of Connect, I'd recommend clicking through on that. Actually, let me just post that, or someone can post it for me. To read up around VMware Connect. So this year, the European VMware Connect event is going to be in Amsterdam, and you can see the details through on that slide. I would highly encourage people to try and get to that event if they can. Feedback on the Connects which we've done so far have been really good. But I also appreciate that not everyone might necessarily be able to secure the funding or the time to be able to go to that event, given the fact that this is a UK and I webinar. So next slide, please, and Rich. So what it is, I would encourage you to do if you're not already aware of the local chapters. So there's several UK chapters dotted around the UK and Ireland, and I would encourage you to look into the free events which they're running. So I'm just aware that there is a London meeting for the London chapter of the VMUG. So feel free to go and take a picture of the QR code for the registration. If you would like to be able to present, then obviously go through and do a call for papers request. So yeah, and if you're in various different parts of the country, then just look on the main VMUG site to find your local chapter, because they will be running their own local sessions. So as usual, please fill in the survey, which we'll release in a few moments. Provide us feedback. Maybe call out Rich for his exceptional live demo skills there of not having any errors, and the I thought that went very well, Richard. So thank you very much. That was smooth. As everyone knows, we run these webinars on the last Friday of the month. And we didn't think that everybody would like to join a webinar on Boxing Day. So what we have decided to do is to bring it forward, because obviously I think the attendance of these webinars has been really strong, and we appreciate everyone consistently coming back to learn more and more around consuming VCF. But we have arranged another webinar for Friday, the 19th of December. We'll be covering VCF with AVI load balancers. So we will send out an updated Zoom during the early part of next week. So that finally leads me on to thank, on behalf of the UK and I solution architecture team. Really appreciate you again taking the time to join us. If you haven't already, then good luck securing some sort of Christmas cheap deals on the Black Friday sales today. Hopefully you get something you wanted, cheaper than you expected, and we will see you again in 3 weeks. So on that note, have a great
Thanks,
week.
everybody. Cheers. Bye.
Goodbye.